Hi, in this video we'll see how to find the length of a loop in a linked list. We'll start with a naive approach using a set, and then we move to the optimal Floyd cycle detection algorithm. Let's first solve this using a naive approach. The goal is to find the length of the loop in the linked list. So the idea is pretty simple. We'll traverse the linked list and keep a set of visitor nodes. Let's take a linked list, for example, let's say 25, 14, 19, 33, 10, and this is connecting back to 19 again. So you see a loop here. We start the traversal from the head using a pointer called current. Okay, and let's have a set here to keep track of the visitor nodes. Node 25 is not in the set, so I add it to the set and move forward. Same thing here. Node 14 is new, so we add it to the set and we move forward. Same here. We add 19 and we move forward. We add 33 and we move forward. We add 10, and now you notice that from node 10 we move next and we reach node 19 again. But how do we know whether a node is a duplicate or not? Nodes can have the same value, right? So the thing is, we are not storing the value in the set, we are storing the node itself, which is a memory reference. Since this exact node is already present in the set, we immediately know that a loop exists. Okay, so the loop exists now. Now we start counting the nodes from the point until we reach the same node again. We visited 3 unique nodes from 19, 33, 10, and we again reach 19. So we have 3 unique nodes. Okay, so the length of the loop is 3. This approach works in linear time but uses extra space because of the usage of this set. So the time complexity will be big O of n and the space complexity will be big O of n as well. So this is a naive approach, and let's look at its coding part now. Alright, here we have a function that returns the length of the loop if a cycle exists. I'm creating a set to store the references of nodes that I've already visited. Let's say visited is equals to set. I'll use a pointer called current to traverse the linked list starting from the head. So current is head, and the counter will be used to count the number of nodes inside the loop. So let us now introduce loop detection check. Now I'll traverse the linked list until either the list ends or the loop is detected. So current is not none if current in visited. Here I check whether the current node is already present in the set. Now we store the loop start. So start of loop is current. Okay. If it is present, I store this node as the starting point of the loop. Now let's count the number of nodes. Let's count the loop nodes. So while true, now I start another loop to count the number of nodes in the cycle. So we increment the count by 1. And like, what are we doing? We are incrementing the counter for every node inside the loop. Then I move the pointer to the next node. So current is current dot next. Once I reach the starting node again, I break out of the loop. So that is, if current is equals to start of loop, I simply break. Okay, now we got to return the length of the loop. Okay, so we return count. Okay, at this point the counter stores the loop length, so I simply return it. Now we got to mark the nodes as visited as well. So if the node is not already visited, we got to add it to the set. So visited dot add current. Okay, so now let's move forward. Current is current dot next. Then we keep moving forward to the next node. And also for the no loop case, like if the traversal finishes without detecting a loop, I must return 0. So the end we return 0. Okay, now let's go ahead and run the code. As you can see, here are the outputs. So for the first case, loop in the middle, no loop, single node or self loop, empty list, 2 node loop. So here are the test cases for your reference as well. This is the first test case for a normal linked list with a loop. This is the second test case, linked list without a loop, single node with self loop, and an empty linked list. So this is a naive approach using a set. It is easy to implement, but it also uses extra space, which is why we'll now move to Floyd cycle detection algorithm. Alright, now let's solve the same problem using optimal approach called Floyd cycle detection algorithm. We'll use the same linked list example that we used in the earlier approach. Let's say have 25, 14, 19, 33, 10, and there is this one loop connecting back to 19. So this particular algorithm uses two pointers. One is slow and one is fast. So slow moves one step and fast moves two steps. In step one, let's say we have both slow and fast pointed here. In step one, slow moves to 19, slow moves to 14 and fast moves to 19. In the second step, slow moves to 19 and fast moves to 10. And in the third step, slow moves to 33 and fast moves to 1, 2. Okay, so they are at the same node right now. The thing is, at some point, the fast pointer catches up with the slow pointer, and this confirms that a loop exists. And the point to be noted here is this meeting point is not necessarily the start of the loop. It is just a point inside the loop. Okay. Once the loop is detected, we keep one pointer fixed and move the other pointer around the loop. So let's say we move the fast pointer from here, from 33, we move one step, two steps, and three steps. Okay. And when the moving pointer comes back to the same node, we stop counting. And the number of steps taken gives us the length of the loop. And here the number of steps were 3, so the length of the loop will be 3. Also, for instance, if the fast pointer ever reaches null, it means that no loop exists, and this algorithm runs in linear time, so it is big O of n, and it uses constant extra space, and it is big O of 1, and that's why Floyd cycle detection is a preferred approach in interviews as well. So now let's quickly code this up. Okay, so firstly I will code the main function to detect the loop using Floyd's algorithm. And once the loop is detected, I will add a small helper function to count the nodes in the cycle. So this is going to be our approach. We have our main function that detects whether a loop exists or not. And I'll initialize two pointers, say slow and fast. Slow is head and fast is head. Now we gotta traverse the loop. While slow and fast dot next. Okay, so this condition ensures that fast can safely move two steps ahead. Now slow equals to slow dot next and fast equals to fast dot next. It means slow moves one step and fast moves two steps. If slow and fast meet, we confirm the presence of a loop. That is, if slow equals to false, we return for now I'll be returning a dummy value, say return 1, and next I'll replace this with the logic to count the loop length. And also for the no loop case, we actually return 0 as no loop exists, so that will be written 0. Okay, now I'll add a helper function here. So def count nodes in loop, let's say we have this function and we pass in meet here. So this function receives the node where the slow and fast pointers met inside the loop. So we start with count equals to 1 because the meeting node itself is a part of the loop. And now we have current equals to meet dot next. We move the pointer to the next node so that we can start traversing the loop. And while current is not equals to meet, we keep moving through the loop until we reach the same meeting node again. Count plus equals to 1. So each time we visit a node inside the loop, we increment the count, and current equals to current dot next. We move the pointer to the next node in the loop, and then finally we return count. Okay, so once we complete one full cycle, the count gives the length of the loop. So this function basically walks once around the cycle starting from the meeting point and counts how many nodes are in the loop. Now let's connect the helper function to the main function. So we have return 1. Instead of this, we make count nodes, and we need to make one pointer to move, right? So let's say we have slow moving there. Okay, now let's go ahead and run the code. As you can see, we got the same output as previous, so the output is right. So I usually write the detection logic first, then extend it to compute additional information like loop length and stuff. Okay, so thanks for watching. Comment on your thoughts below.